Find the volume of the solid when the region bounded by y is equal to x squared, y is equal to 4, and x equals 0 is rotated about the line y equals 4. Let's begin by drawing a rough sketch of what this solid revolution is going to look like. So we have y is equal to x squared. All right, so that's a parabola. So it's going to go through at 1, 1, 2, 4, and the origin. Okay, and then it's being rotated about the line y equals 4. So we have that line happening here. And it's also bounded by x equals 0, or the y-axis. So if we look, we can see that here's that parabola, and when you rotate it, it's going to look something like this when you're rotating it about the line y equals 4. And because we're rotating it about a horizontal line, we're going to be using the disk method and the integral in terms of x. So we don't have to change any of the notation necessarily for the integrand. So our volume is going to be pi times the integral. We'll look at the bounds in a minute. We have x squared as part of our radius here, but it's not just x squared and the x-axis. So we have a 4 here, that's kind of the upper bound that's being rotated. So we're going to have 4 minus x squared as our radius, and we're going to square that, and we're integrating with respect to x. And now if we look at our x values that we have, the lower bound is going to be 0, and the upper bound, or where the axis of rotation meets our function, is at 2, 4. So its x-coordinate is 2, making it the upper bound. So now let's rewrite our volume equation. We still have pi times the integral from 0 to 2, but we can take 4 minus x squared and square it. So that's 4 minus x squared times 4 minus x squared. That's going to give us 16 minus 4x squared minus another 4x squared, or minus 8x squared, and then plus x to the 4th. And we're going to integrate with respect to x. Let me rewrite this exponent for clarity. It's going to be a 4. So we still have our pi, and now we can integrate. We're going to have 16 minus 16x, I should say, minus 8x to the 3rd divided by 3 plus x to the 5th divided by 5. And we're going to evaluate this from 0 to 2. And when we do that, we'll have pi times 16 times 2 is 32, minus 2 to the 3rd is 8, 8 times 8 is 64, so we have 64 thirds, plus x to the 2 to the 5th is 32 over 5. And then we're going to subtract. If we put 0 in for all of these terms, it's just going to be 0. And again, I'm going to update this 4 and 64 for clarity. And now in order to evaluate what we have here, we're going to need a common denominator. And notice all of our terms here are written in terms of pi and as fractions. So let's keep working with our problem that we have here. Common denominator is going to be 15. Okay, so 32 fifths becomes 96 fifteenths. 64 thirds becomes 320. And 32 becomes 480 fifteenths. And then if we evaluate this, we'll have 160 fifteenths plus 96 will give us 256 fifteenths times a pi, or 256 pi divided by 15, or answer choice B.